Okay. Should be good. Hello. Okay, I'm just going to wait for a little longer just so everyone can trickle in. Got quite a few questions to do today. And again, we'll just get as far as humanly possible as per usual. Hello, hello. Okay. So, God, wait a sec. Okay. This should all be good now. I'm glad you are. So again, I'll just give it another, let's say, 2 minutes, and then we'll start going through some of these questions that people have given. Again, quite a few different types of questions. Okay, W stream, of course. Every stream is a W stream. Okay, so we've got a few people in. This was, well, again, I'm just going through the chat, so if you do want to submit questions, go onto the Discord, and there's a stream questions little button, little channel. You can just post an image of your question, and I'll do it. If I message you asking you where you got it from, it's just so I can get like a clean copy like this. So I can't remember who submitted this, but I basically asked, tell me where it's from, and they gave me the chapter of the textbook, and I copied it, and it looks nicer, so it's easier for everyone to see. So either way, we have this handy question here. So a swimmer dives into a pool. Her position P underwater can be modelled in relation to a horizontal distance as a quadratic equation. So it's going to look like a big U. So he jumps in, it's like a U shape. The position of the bottom of the pool is a linear equation, because as you can see, it's a straight line, right? So the actual bottom of the pool is linear. Determine whether this model predicts that the swimmer will touch the bottom of the pool. So, for this to happen, these two equations, we're looking for the point of intersection. So if I draw this out, and please forgive me, is you're going to have like a U shape here. And we're looking for the point of intersection if they intersect. So this just means if they intersect. So when we look for a point of intersection, what we do is we equate the two equations, don't we? So that's what I'm going to do here. I'm going to write half x squared minus 3x. Actually, I'm going to make the pen a little thicker just to make it look a bit nicer. Is equal to 0.3x minus 6. Now I'm going to write this all again, just in decimals, just to make it a bit easier for me. And I'm going to move everything over to the left-hand side. Because remember, when we do something like this, we're trying to solve it, right? It's a quadratic. He's already straight to the point. Yeah, I got told that I need to speed up a little bit by some of you guys, and that's a very fair assessment. So I'm going to move everything over to the left-hand side. We have 0.5x squared, and then minus 3x minus 0.3x, we minus 3.3x, and then plus 6 equals 0. Now, I don't actually care about solving this. If you look what it says, it says determine whether. That's like an if, right? This model predicts that the swimmer will touch the bottom. Well, if they do touch the bottom, it means we could solve it. So, we're looking at the discriminant. So I'm going to work out what b squared minus 4ac equals. And then depending on if that's 0, negative, or positive, I'll be able to tell if it touches. Okay, so let's actually work out what the discriminant is. Well, the discriminant b is going to be negative 3.3. So let's do that. Negative 3.3 squared minus 4. A is 0.5 and C is 6. So see what that gives me. And again, I'm just going to shove it in my calculator because again, it's all calculator exams for A levels, so you don't even need to worry about doing the maths, at least mentally anyway. 0.5 and then multiplied by 6. And that gives me negative 1.11. So what does that mean? Well, it means it's less than 0. Therefore, there's no solutions to this quadratic. So what does that mean? Well, it's just like in my diagram. It means that the swimmer and the bottom of the pool do not touch each other. They do not intersect. So therefore, they do not... actually, what is the wording of the question? So the swimmer will not touch. Let's write it like it says in the question. The swimmer will not touch. Swimmer will not touch. Now, if you notice, this is a 5-mark question. 5 marks. And it's an exam question, that's why there's an E there. There's not that many steps. Well, 1, 2, 3 steps, really. Because again, that's why I like the modelling questions. Because if you understand the maths behind the modelling, you can get 5 marks in just a few lines of working out. It's really, really good. So these modelling questions, I know they're harder, but you get a lot of marks for maths that isn't really that crazy. They just want you to be able to apply the maths to a situation, okay? So, assuming that's all fine, let's move on. And I left quite a bit of space. So this question is actually from mechanics. So it says a particle P is moving along a straight line, such that at time t seconds, t is greater than or equal to 0. After leaving the point on the line, the velocity is this. Find the value of t at the instant when P stops accelerating. So, part A. So, when we have this kind of information, I just want to point this out. I'm going to go this really lightning fast. When you have an equation for displacement, you can differentiate to get velocity, which you can then differentiate again to get acceleration. Okay? Now that's a bit of mechanics. So in other words, I'm looking at when it stops accelerating. So that's when A equals 0. But I don't have an equation for A. So what I need to do is expand these brackets and differentiate velocity to get an equation for acceleration. So let's do that. Velocity equals, so if I expand that, we get 7t plus 14 minus 2t squared minus 4t. Lightning fast, just collect the like terms. We have negative 2t squared burst. 7t minus 4t is 3t. Thanks, Nithika. And that's plus 14 on the end. Whoops, that's a 4. So again, acceleration is just the differential of the velocity. Now that might sound scary, but remember differentiation is not that bad. What you do is you bring the power forward. So that now becomes minus 2 times 2, which is minus 4. And then you subtract 1 from the power. Well, 2 minus 1 is 1, so I don't need to write it. Do the same thing again. Bring the power forward, that's a 1, so that stays as 3. And then that becomes t to the power of 0, which is 1. So that's just nothing. So it's just negative 4t plus 3. Now what about the 14? Well, think about what differentiation is. It tells you how quickly each of these terms is changing with respect to t. But this doesn't change, it's a constant. So its rate of change is 0. So if you like, you could have that as a plus 0. Have a GCSE history mocked. Have a nice day, everyone. Good luck, Hyperslane. So, there we go. So A is equal to negative 4t plus 3. Now, what does the question actually say? Well, it says when it stops accelerating. So that's when acceleration is nothing. So 0 equals negative 4t plus 3. So 4t equals 3. So t is equal to 3/4. God. Hello, Tenzin. Oh God, Sky King. So that's 4 marks. I know that sounds pretty scary. Hopefully you see it's not that bad. Okay. God, my voice is already giving out. I had a few lessons afterwards. Okay. So what about find the distance of P from O at the instant when P changes its direction of motion? Is this Suva and differentiation? It's not. It's something. It's a topic called variable acceleration. It's called variable acceleration. I think it's chapter something. I can't remember what chapter it is. I'm not going to lie to you. Okay. But it's towards the end of mechanics. So, find the distance of P from the origin at the instant when P changes its direction of motion. Okay. So, when will that happen? Well, if I look at V at the start, here, when something changes its direction of motion, it means the velocity changes sign. Okay? That's what it means. The velocity changes sign. The example I like to use is if I throw a ball upwards, we have V. When it gets to its top, the V is 0. And then as it starts to come down, it's going to come down with negative V. So can you see that the V changes sign? So in other words, if I want the time when it changes its direction of motion, I'm solving B equals 0. So solve that. So we have negative 2t squared plus 3t plus 14 equals 0. Now, I'm going to use a calculator to work this out. Now, some students say, it says, in this question, solutions relying on calculator technology are not acceptable. Now, this doesn't mean you can't use a calculator. It means you can't solely use a calculator. So I can solve this equation using a calculator fine. But if you look, I still have working out. That's what they're looking at. They don't want you just to shove the whole thing on a calculator. So, menu, go down to write once, equation / func, polynomial. Polynomial degree is always going to be 2 because we're solving quadratics. We have negative 2 in front of the squared term, 3 in front of the linear term, and a 14 as our constant. We have 7 over 2 as one time. And we should get another time, but you'll notice something. It's a negative number. Now, I had a Spanish map today, but I couldn't leave early. That's a shame. So, if I look at the question, it does say t is bigger than or equal to 0. But also think logically for a second. Can time be negative? If I say I'm going to talk to you in negative 4 hours, does that mean anything? You might say it might mean 4 hours ago, but it doesn't really work that way. So, we're not going to include this value. So we have our value for time. Brilliant. Okay? It says find the distance of P from the origin. Well, we need to know what S is. We need to know the displacement. So, I said to go from S to V and V to A, we differentiate. To go backwards, well, what's the opposite of differentiating? It's integrating. So we need to integrate velocity with respect to time. So, B is equal to negative 2t squared plus 3t plus 14. S is going to equal the integral, negative 2t squared plus 3t plus 14 with respect to time. So, how do you integrate? Well, you do the opposite of differentiating. When we differentiate, we brought the power forward, then subtracted 1. In integrating, we add 1 to the power, and then divide by the new power. So negative 2t, add 1 to the power, divide by the new power. Is variable acceleration on the EdXL spec? It is. Yeah, variable acceleration. Give me 1 second, I'll show you in the book. It's an EdXL spec question. So, keep going. 3t, add 1 to the power squared over the new power, and then 14t. But also, you have a constant term, c. It is as. It is as. So let me show you quickly in the textbook. I'm just remembering which chapter it is. Variable accelerations, page 181 in your textbook. Almost there. A bit further down. My God, how... Okay. See, it's page 181 in your textbook. So if I show you this chapter here, it's called Variable Acceleration. And yeah, it's covering everything we're talking about here. So we have these equations. It won't show you the differentiation just yet, using differentiation, etc. So yeah, it is 100% a AS topic, and it is at Excel. Okay. So, God, brilliant. Now, I can say that C is going to be 0. I'm good at stats. Shall I do S2 or M1? Up to you. If you like stats, then do S2. So, now, I need to know what that constant term is. Well, I know that t equals 0, the displacement should be 0, right? It should be at its original spot. So if I sub in t equals 0, s equals 0, can you see that c is going to be equal to 0? Because all of these terms will cancel out. So, my equation for s is negative 2 over 3 t cubed plus 3 over 2 t squared plus 14t. And all it's asking me is the distance from the origin. So I just sub in my time is 3/4. Sorry, not 3/4. 7 over 2. Whoopsies. Spoilers. T equals 7 over 2. So we get S equals negative 2 over 3. 7 over 2 cubed plus 3 over 2. 7 over 2 squared plus 14. 7 over 2. Good Lord. Shove it all in the calculator. Job done. Easy peasy lemon squeezy. Uh, 7 over 2 is just 3.5. That'd be easier for me. Oops. Are normals AS, and if so, what chapter? Normals? What do you mean by normals? As in like normal lines? Then yes. Yeah, so equations of normals come up in the circles chapter. So coordinate geometry. And we get 38.8 meters. You're very welcome to 3SF. Whew. Okay. So far, is everyone okay? We'll keep going. We've got some really spicy questions coming up in a bit. So, we're getting through a lot. Okay. Here's an equation of the normal. Have a read through that just while I drink some water because I'm dying. Okay. So, find the equation of the normal to this long expression. And this is where a lot of students turn off. And they just go, I don't get it. I don't get it. Relax. What is a normal? A normal is a line that's perpendicular to a curve. So, what do we need? I need the gradient of this thing. And then the normal will be minus 1 over the grad. And then I have my coordinate. Remember, to find an equation of a line, you need two things. You need the gradient and you need a coordinate. We can get the gradient from the curve, negative 1 over it, and the coordinate they've given us. So how do we work out the gradient? Well, how do you work out the gradient of anything? We differentiate. So y is equal to, and now I want to write this in index notation because we can't really differentiate fractions yet. So I'm going to make that x to the minus 1 minus 3x to the minus 2 minus 4x to the negative 3 plus 7 over 4. Now we differentiate. And this gives me an equation for the gradient, because the gradient of a curve will change over time. That's the definition of a curve. Remember what I said? Bring the power forward first. So negative x, subtract 1 from the power. Bring the power forward, plus 6, because 9 is 3 times minus 2. X to the minus 3, plus 12, minus 4 times minus 3, right? X to the minus 4, and constants go away. So that's gone now. That is our equation for the gradient. Now that is hideous. So how do I work out the gradient? Well, you sub in the coordinate they give you. So at x equals negative 2, dy by dx, and you're just subbing it into that expression. And then that is your gradient, okay? So, get our calculator out. We get to do something fun. Yay. Whoops. Negative 2 to the minus 2. You could make it a fraction again if you really wanted to, but it's not necessary. Thank you, Sky King, but again, that's kind of my job, right? That's what a teacher does. Well, hopefully, breaks things down and to make it easy, make it easier. Maths is all about logical steps, okay? So it looks scary, break it down, okay? That curve makes me want to vomit too. Slow down. Negative a quarter. Nice and easy. Further maths isn't easy, no. So, now we can actually work on this. The gradient of the normal, I'm going to call that mn, is the negative reciprocal. Which, by the way, if you're ever unsure, do it on your calculator. Do minus 1 over minus 1 over 4, and you should get 4. So if you're ever unsure, just do it on a calculator. Okay, now we have y equals, I like to use mx plus c, but we have 4x plus c. If we sub in these coordinates now, we can work out all of the values, okay? When is a hard A-star question video coming out? I'm editing it now. The first one I've started with is Suvat, and then I want to do logarithms, okay? So, we have 1 equals 4 times minus 2 plus c. So we have 1 equals minus 8 plus c. So c is equal to 9. So we have y equals 4x plus 9. Now it says to give it in this form. ax plus by equals c. Okay, fine. I will do that as, move this over. We have negative 4x plus y equals 9. That fulfills the criteria. So yeah, I have recorded a bunch of really hard A-star questions. I've started with Suvat, and I might do each question gets its own video because they're quite long. They're about 10 markers, 12 markers. And then I'm going to move on to logarithms because logarithms is the next hardest one. So people hate Suvat, people hate logarithms. I'll do it in that order. But again, if you want to let me know which one you find difficult, I'll let you know. From WME. What's W? Wait, do you mean MME? Maths Made Easy, or? Okay. Next question, and this is the last one. Quite small. But this is really common. First principles, a lot of students suck at. Okay? And that's fine. I got quite a few questions from that exam board, or like a website. I can't remember what the hell it's called. Anyways, so you learned this in the lesson, yeah. You need to be able to do this for any derivative they give you. Okay? Let me show you how it works. Let me take it nice and slowly. So, we're told that f of x equals x cubed. And to work out the derivative, we would do the lim as h tends to 0 of f of x plus h minus f of x over h. Yeah? No, you cannot differentiate it normally because it's proved from first principles. So this is the definition of a derivative, okay? You have to do it. The examiner will laugh at you, yeah. So, first things first, I want to write out what f of x plus h is. That would be, well, think about it, it's just like a graph transformation, right? I'm replacing x with x plus h. I'm going to show you the common pitfalls that I see in this question, okay? So the first one is, well, let's write out what it's asking us to do. So lim, as h tends to 0, that is going to be x plus h cubed minus x cubed over h. The thing that I see some students do, which it's crazy, is say, well, when h tends to 0, and they get rid of all of the h's. What do you mean? The limit is the very last thing you do. Because if I tend this to 0, technically this could be an infinite thing, right? Because I'm dividing by 0. But the problem is functions reach 0 at different speeds. So, if I make h tend towards 0, it will not reach 0 as fast as h cubed. H cubed reaches there faster. So you can't do it that way. So what you're going to do some algebra. In fact, it's mostly algebra. Here's what you do. So I hate having to write this out each time, but I don't want to confuse you. Expand the brackets, simplify, see what happens. So let's do x plus h, and x plus h. I can't remember what this is off the top of my head, so we get to do this fully. What I'm going to do now, I'm going to do something a bit cheeky. I'm not going to write the limit just for a bit, because otherwise I'm going to get carpal tunnel. So that is going to be x squared plus 2xh, or 2hx, either way round, plus h squared minus x cubed over h. Expand that again, we get x times x, x cubed, plus 2x squared h, plus h squared x. You know what, I should write this the other way around, really. So technically variables should go at the end. So technically I should write it like this. I'm being a bit picky here, not gonna lie. But I'm just feeling in that mood, you know. Technically, constants come first. Let's do that. Where was I? Okay, and then plus hx squared plus 2h squared x plus h cubed minus x cubed. And then you're simplifying. So, x cubed and x cubed go away, which is nice. Let's do the hx squareds first. So that's 2hx squared plus hx squared. So that is 3hx squared. So I can tick those two off. Then I go to the x's. I have h squared x plus 2h squared x. So that's 3h squared x. And then plus h cubed. All over h. Divide through by h. So again, the h goes here, 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 here. And you get 3x squared plus 3hx plus h squared, okay? Now let's bring back the limit. Let's look at the limit one more time. We have lim, h tends to 0, of this. Now that is not a fraction, which means if I make h 0, nothing naughty happens, right? Nothing bad happens. Here, we might get an infinite, that's scary. But here, if I make h tend towards 0, well, this term will go away, and this term will go away. So what am I left with? I'm left with 3x squared, which is what the question asked me to show. You need to be able to do this for anything they can throw at you. So they could have changed this to be x to the power 4, 2x squared, 3x cubed. You need to be able to do it. So follow along the steps. The limit is the very last thing. If you do the limit and get the answer, then you're good. If you do the limit and you get something weird, you're not good. God, my voice. How's that so far? Difficulty 2, eh? You have to be able to do this with sine and cosine soon as well. You don't need a final statement if you write this. So if you write tends to 0, tends to 0. You can also write like QED at the end, which is Latin for as stated in the question. But yeah, you just need to show that the limit's going to 0. Oh. So we've got a couple more stream questions. They want help with part C specifically, but I might do the whole thing because it's logarithms. So let's go. So I can zoom out a little bit. Cool. Logarithms sucks normally. So. Oh, I see. Okay. Anyway, sorry, I got distracted by something. Here is another application question for exponentials. Now, once you've done the exponentials chapter, you'll find that exponentials and logarithms are the same thing. In the sense that if you have a question about exponentials, you're going to have logarithms. If you have a question about logarithms, you're going to have exponentials, okay? They're inseparable. So, the first few parts, and I just want to point this out, this is a very typical question structure. Get that form in part F. Part F. Anyways, okay. Oh, part C. Yeah. No worries. We're going to have a look at it. So, x is equal to de to the power of negative 0.2 t. Where x is the amount of blah, blah, blah. Yada, yada, yada. First dose of 15 milligrams is given. So that means d is 15. Use the model to find how much is in there. Cool, this is easy. X is the amount in the bloodstream. 15 is our initial dosage. The e to the power of minus 0.2, and it's 4 hours. God. E to the negative 0.2, 4. That should be good. And it says to 3 decimal places, so 6.740. Okay, 6.740. Perfect. 2 marks. Not bad. A second dose given 5 hours after the first dose. Using the same model for the second dose, show that the total amount is 13.754. Well, what we're going to do is for the first dose, x is equal to 15 e to the minus 0.2. And that's 7 hours after, right? Because look, 2 hours after the first dose, after the second dose, would be 5 hours after the first dose, plus another 2 hours, right? Because it's 7 hours after the initial one. So, put in the 7, equals, once again, let's just put this in, 7, boom. It says to 3 decimal places, let's just do this to 3 decimal places, 3.699. And then the second dose, well, that's only 2 hours after the second dose. So we're going to sub in 15 e to minus 0.2. I realised I probably shouldn't have rounded just yet, but oops, mistakes happen. Probably should have kept it a bit more exact. 10.055. So in total, you would add them together, which can you see would give you approximately 13.754. So if any of you want to become doctors, that's the type of stuff you get to do. Although, to be honest, the computer probably does it for you, so don't worry too much about it. Okay. So, this one's going to be interesting. No more doses are given. At time t hours after the second dose, the total amount of the antibiotic in the bloodstream is 7.5 milligrams. So, Let's write this out. X, actually no, hang on. Okay, does it make sense that I could have written this all on one line? I could have written this as 15e to the negative 0.27 plus 15e to negative 0.22. Does that make sense? You could have written that all on one line. Same thing, right? So, let's do the same thing. Our total in the bloodstream is 7.5. And that equals 15e to the minus 0.2. Now, the time is where things are going to get a bit tricky. Because it says t hours after the second dose. So that means the first dose was t plus 5 hours ago. Plus 15e to minus 0.2 t. I hope that makes sense. Hopefully. What's a good way to revise Year 12? I can't even see it, there's emojis in the way. Year 12 maths. I mean, do what we're doing right now, right? Go through as many hard questions as you can. The harder the better. Yeah, you need to go through more questions, more actual difficult questions. Don't stick with the easy stuff. Your brain should hurt after you revise. Okay, so there's a bunch of different ways we could do this. And I'm just thinking about what the most efficient way would be. So I could take the log, because it says ln and it has over e. That's one thing I could do. But I'm going to start factorizing just a little bit. Because I believe if I factorize, my life is going to be a little bit easier. So if I factorize out first of all, I'm going to divide both sides by 15. That. And the next thing I'm going to do is I'm going to expand this bracket as well. 7.5 over 15 is just a half, right? That's easy. E to minus. And there's a reason why I'm doing this, I promise. I'm not just trying to kill time. Oops, there shouldn't be a 15 here. My apologies. E to negative 0.2 t, like that. Now, if you remember your rules of indices, you add powers when you multiply. Or if you want to say vice versa, when you're subtracting, you're dividing. So in other words, I could write this as e to the negative 0.2 t divided by e. Factorize out the e to the negative blah, 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 blah. Okay. Move that over to the other side, which is going to look hideous. But it's what it is. It will clean itself up soon. Take the natural log of both sides. Should we clean this up first? Ah, okay, I see what they've done. Okay, never mind. We won't need to clean it up. So ln 1 over 2. They've done something very clever, which is good. Equals negative 0.2 t. Can you see we're getting closer and closer to this little thing here? Hey, deviation. So, I just want to show you guys something. I'm going to write it over here just because it is related, but it's not directly related. 1 over e plus 1. I could put that all, I could write that as, how do I want to write this? To negative 1. That's what I want to do. And that is going to give me the form, right? So, hang on, was there a number in front of here? There is. It's the same number too. Oh, we've done it. We've done it. Okay. So, we have 2. One. Again, I'm ignoring the right-hand side for now, because if I expand this bracket now, watch what's going to happen. In fact, I'm going to write it slightly differently as well, because I've seen what's going to happen. We put 2 first, plus. If you look at this inside the bracket, b plus b over e, b is 2. Using the power law, we're going to bring the minus to the front. Divide both sides by negative 0.2, so the negatives will cancel. That brings me to 5 ln 2 plus 2 over e equals t. So, a was 5 and b is 2. They're both integers and b is the same in both cases. Cowabunga. Hopefully that was okay. There's someone called Nosh send that in. I'm not. Someone did say. So Noah, I'm assuming that was you. Hope that makes sense. Oh, sorry, Dylan. Yes, I see your question. How did I miss that? Okay, you wanted me to do. Was it question 16? Did you say? Is it question 6? Yeah. Okay, question 16. Let's bring that over. It's kind of hard to see, I'm not going to lie. But I'll do my best. God. I might have to draw this out again. Okay. Good now. Okay, let's do this one. So the diagram shows a sector of a circle. So that's OAB. Where's A? Oh, A is over here. Okay. Oh, jeez. Okay, I need to thin that up. There's A there. Blah, 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 blah. Okay. Line AC is a tangent, which means that is going to be 90 degrees. And OBC is a straight line. OBC. Oh yeah, OBC is a straight line, that's fine. The region R is bound by the arc. Bound by the arc AB, and the lines AC and yeah, okay, that's God, that's so much information. All right, find the area of R. Okay, so easiest way to do that is find the area of the triangle here, and then subtract the area of the sector. That's what I would do. Don't think we have. Do they give me all the information? So R is 12. Is C also on the point of a sector? No. Okay. So and DB. Oh, it doesn't say anything. Okay. No worries. So this is a right angled triangle, and we want to find the area. So we want to do base times height. So base is this. Height is this. Radians is just a unit for angles. It's really not that bad. So if you have a look, that's the opposite and the adjacent side. So we can... Whoa. Okay, that was careful. We're trying to work out x, right? Because we need the base and the height. Because opposite the right angle is the hypotenuse, which is OC. So x would be... So, well, let's just do it. Tan 1.2 equals opposite, which is x over adjacent. So x is equal to 12 tan 1.2. Again, even if you don't know what radians are, this is a good question to look at. The only difference is that if you notice, there is a D on my calculator. Can you see that? That means I'm in degrees mode. I need to go, whoops, into radians mode, which is angle unit radian. And I do the same thing. It's no different. Boom. 30.9. That seems quite big. All right. That seems very big, doesn't it? All right. I mean, is what it is. Okay. So the area of the triangle OAC. So area OAC is just a half base, which is 12 times 30.9. Let's do that. So answer times 12 times 0.5 gives me 185.19. And then, wait, this is 8 marks? Oh, what on earth just happened? Alright, hold on. Oh. Okay. This is 8 marks. That's really generous. Okay. So as you can see, I've got the area of the big triangle. Yeah? And I'm just going to subtract, just a random YouTuber, great stuff there. Thank you very much. I'm just going to subtract the sector here. Okay, I'm just going to subtract it away. Have a second just to make sure that makes sense. I'm just responding to something. Yeah, make sure that makes sense to you. And all we need to do now is sub it into the formula. Now, I'm not sure if you know this, but area of a sector normally is angle over 360 pi r squared. Okay? Usually. But when we use radians, this bit just becomes theta. So it becomes quite short, which is nice. So instead, we just have a half r squared theta. Sorry, I should clarify. All of this becomes a half theta, basically. So the area of OBA is just a half r squared times theta, which was 1.2. So 0.5 times 12 squared times 1.2 gives me 86.4. So all you need to do is subtract them. So 185.19 minus 86.4 gives me 98.79. Does it say? It says two decimal. Oh, thank God, two decimal places. 98.79, and the units are centimeters squared. 8 marks. Bad. God. Oh. Anyways, wait, I just want to tick this one off. Where is it? Where am I looking? That is the area of the shaded region. So, the last bit is find the perimeter of DAB. Okay. Ah. Okay. So for part B, so I'm going to quickly go through this. So DAB is, how do I want to write this? How do I want to write this? Because things now I can't see the image properly. I'm going to rub some of this stuff out. Is going to be this arc length here. Okay. And arc length is just r theta. So I'll call it BA. equals 12 multiplied by 1.2, which I'm going to use a calculator for, just to be completely honest, is 14.4. Good, we know the first one. And to DAB. So the other things we need is we need this point here and this point here. Now I'm looking, that is all the way up to B, and it's kind of annoying, I can't see properly. Okay, so we have a smaller triangle and a bigger one. Now because they're parallel, I'm not sure if there's more information, but if they're parallel then we can use scale factors to work them out. But I'm not sure. AC and BC, okay. I mean, unless they want you to, yeah. So that is all the information they give you. So yeah, from there, all you need to do is, so we've worked out BA. If you're working out DAB, which as you can see would be there to there to there, we've worked out the curved area. All you need to do now is work out these two sides here using scale factors or trigonometry. Just going to check one thing quickly. Okay. Okay. That was a hell of a lot. I hope that makes a bit more sense. Yeah, we got through quite a bit. And I've checked them all off. So again, don't forget you can, in the Discord, on the stream questions chat, you can just post any questions that you want me to do, and I'll do them in the kind of following weeks. Next week there won't be a stream because I have a dentist appointment, and sadly the only time they had was 6 PM, which sucks, but yeah, I most likely won't be here for this, which is a shame, but that is just the way it is. Yeah. So anyways, I hope you guys enjoyed. Tree, if you submit it on Discord, that's the best way to do it, because email gets too messy. I miss some of the emails. Yeah. Hope you guys enjoyed, and see you guys not next week, the following week, when I'm finished with my medical stuff.